start recording now. Yeah. I'm gonna check if the stream is even working, because that'd be great. Let's see.
And I thought it brought a different tone and a bit more maturity to the series. I think the show from the 80s and 90s was a
Oh! 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 Like, hello. Hello. Easy. No, just so that I'm just showing something, like trying to get people. I kind of kept it most simple because I think no one knows what's going on. I was like, should I do all my MIDI stuff and everything? I was like, I'm still pretty new to everything.
You have no way where you're using your keyboard.
Yeah, I'm just using my keyboard today.
That's a beast of a laptop.
Yeah, it's pretty beastly.
More of a desktop than a laptop.
So yeah, I'll be trying to start pretty blankly and explain some stuff, and then showcase what I got and stuff. And I'll probably be trying to make it really interactive, ask people like what their experiences are and all that stuff. Probably like wait a bit.
In the middle of midterm.
Oh yeah. I mean, I don't know how many people actually show up, but I think the point is that it was cool to get the experience of doing all of this. Cool.
Have you ever done stepping through?
No, this is my first event like ever, so we'll see. Uh, All good.
So we're going to take photos, and thank you so much. And I will give it over to Roxanne Harris to tell you all about live coding.
Yeah, sure, Justin. Yeah, sure.
So I'm going to say something very briefly. It was not prepared. Roxanne said she wanted me to.
Oh, Jesus.
No, it's fine. Because here's what I'm going to say. I'm really excited you guys are all here. And I just want to say why I'm excited that you're here. One, my God, it's been a long time since we've had an event. It's sparse, but it's in person, right? This is nice. The thing that I'm excited to see by having you here is that Roxanne has been doing some really amazing stuff over the course of the semester. It's been pretty wonderful to watch it develop. And I'm just really excited that other people are going to get a chance to see what she's been working on. It's pretty wonderful. The kind of work that she's doing is, you're going to learn all about it, but live coding music. And I can't speak for all of you, but I can speak for myself. It's changed the way that I think about music, just watching her learn the process. Thinking about sound or a performance or a score, not as like some pre-scripted thing that exists on a series of lines that we look at from a distance, but rather a kind of growing, living, organic entity that we can touch and push at and prod, and we can do it in all kinds of different ways. So I hope that you will all be as inspired by Roxanne as I have been by Roxanne, and I'm really excited that we all get to be here in person to enjoy it. So thank you guys. And if I'm walking around taking pictures, it's just because I'm a guy. Don't mind me. All right?
Thanks. Hey everyone, can you hear me fine? Let me know if there's any audio issues, and I can try to project. My name is Roxanne Harris, as said. I'm a super senior in Grace Hopper College, studying computer science and music. I only started live coding because I needed to figure out what to do for a senior thesis where I didn't want to do double the work. So I was like, I got to do something that combines the two. And I had taken some computer music courses here at Yale with Scott Peterson, algorithmic composition and sound synthesis. And there I learned a lot about coding music, executing it, and then it, produced a file that sounded cool. And it was a very cool experience, but I didn't realize until just early the last year that there were people that were not only coding music, but using programming as a performance tool, like actually live coding in front of people. I had no idea that this whole world exists, and it's wide and vast, and it's become something that's my new passion that I could see myself doing for a very long time, getting involved in. And so that's kind of the kernel that produced we are today. I'm going very off the cuff because I've never done something like this before or talked to anyone about this, or talked to people about, talk to people about off the cuff, but I want this to be a very I didn't know what was going on. You probably are all here to try to figure out what's going on. Feel free to as if we're a one-on-one, just ask me questions and stuff. I probably could always explain things better, so I'd like it to be kind of casual and not me just talking all the time. So to help kind of contextualize some of the stuff that I do or what it can look like outside of the context and just talking about it with you all today and maybe doing a little demo. As you see when you came in, I have prepared a bunch of videos that I find online, some of which I did, some of which that are algorithms, some of which are just all different kinds of content that involve live coding. And so I can probably reference those as I go along today, but those are some of the ways in which I first experienced live coding and then make my own stuff. And some of those parties and stuff I hope to be doing. So yeah, just kind of taking outside of just the world that we're in right now. So yeah, what is live coding? Pretty much the same way a software engineer would write programs and build all the apps that we use today and whatever applications we have. I write programs that are designed to produce audio in real time, and once the program is running, I can still make it to the program that could be saved and then affect the music in real time, effectively making it, well, live coding. I only realized maybe like a few months into, trying to explore this whole world that I had actually heard of live coding before, but in a different context. It was actually Professor Aspinaz. I think I was taking 223 for comp sci, and he was like, live coding. He's like, oh, like live code for class today. And it's like, you used to have such neg context where it's like, oh, like I'm going to like mess up during the thing because I didn't pre-prepare my code as an example, you know what I mean? And like talking about live coding as like something that is like risky, something like not to be preferred and like a weird thing to do like in presentation. And so it was weird like coming back to that and those like quirky parts about live coding in front of a class and that kind of presentation is actually, can be recontextualized in terms of like making music and be something really positive. So I thought that was dope. But that's the crux of what I've basically been doing, crux of what I can talk about today. I'll just begin other than, I'm just trying to give like as much context as to what I'm doing first, and then I want to open it up to like questions and try to make it a little bit more conversational. But let me see if I can, let me check if all is actually coming through. Maybe a quick sound check, hold on. Yep, okay, that's working, that's great. And I'm gonna go to here, and this is also my first time doing anything live streamed or anything and everything, so bear with me if there's any weird parts here. So, yeah, okay, cool, yes, word, did it, I did the thing. What we have here is my deliverable for my computer science senior project. I delivered a set of these web pages where basically I convinced the DOS to be like, usually for a thesis you would think, hey, you got to do something that you're an expert in, and really go into that and discover something new. But I was like, hey, this is cool. Can you just let me learn a new skill actually, and then I'll document my process and try to inspire other people to do it. They gave me the go-ahead, so now we're here. So yeah, I think my abstract is a great place to start. I won't read all of it, but use it as a source of reference to paraphrase. I think it's always ironic that I started my computer science thesis senior project abstract with the sentence, programming is hard, which I think is really apt, because I think most of the times that, if you encounter computer science majors at Yale or even music majors or anybody who specializes in a certain field, you usually feel this feeling of oh, my brain doesn't work that, I can't do that, or that's crazy, you must be a genius or X, Y, and Z, and all this language around separating the in crowd versus the out crowd, the people who are in the know. And I think that, an argument that I tried to make that I'll reiterate later is that living in any context, but especially just keeping within the scope, it kind of begins to break down those barriers and those boundaries of what can programming be and what could that look like and how it could change the way that we think about technology and how we interact with it in the future, as well as democratizing and loosening up these really hard set definitions that we so often take for granted. So, as I said, programming is hard, and it's a statement that remains commonplace in today's classrooms, workplaces, academia, and the media. And rather than just trying to argue about how difficult it is, I wanted to see ways to demystify it. I think a lot of what makes it seem difficult is the mystery surrounding it. Also, people's, I think in general, computer science education and how people talk things, their inability to communicate their ideas in a way that people could find common ground and follow. So I thought that let's find a way to promote creativity, engagement, and accessibility, which is something that can always be improved in any education system, especially computer science. So I tried to challenge preconceived notions by doing a live coding environment where I think the design of the performance aspect, but even the technical design of how these systems are, the architecture of these systems and how they're built and designed, a lot of them can tackle a lot of these issues that I've been talking about. And the community talks about the community aspect of live coding, where I went from not knowing anything about live coding and taking basically last semester to really go head first in to now this semester. This is my first of many events where I've now gotten the opportunity where next week I'll be traveling to San Francisco to perform do like a last minute performance, but do a performance to help like TA class on live coding music, as well as, a New Haven Festival will be coming up, and then just try to do all these things. And it's kind of like stuff that I never thought that I'd be able to do, where I want to take the opportunity to be like, for a long time, my background, I guess this is a good segue to talk about my background. I started playing the alto saxophone in like the 3rd grade, and I've been involved in like classical and jazz music and musical influences all my life. Throughout high school, I played a high school band for Jazz at Lincoln Center and had a lot of performance opportunities at places like Carnegie Hall and Blue Note and things like that. So I had a lot of like performance experience, but it was always playing other people's music or playing in a band or, reading music or improvising within this limited context. I didn't really pursue that as much coming to Yale because I think initially I auditioned for a few bands and I tried to get in a few groups and I didn't make the cut initially, and I felt kind of like, oh, maybe like it's just not for me, and I just kind of focused on the computer science side of things. I actually initially started as a computer science and mathematics major and was like, oh, I guess like that creative stuff, I guess I shouldn't anymore. And I felt paralyzed for a really long time to make things of my own and shit. And I feel like I've definitely regained that power and that agency within myself with live coding. And I want to kind of, as best as I can, communicate, because I'm still new and I'm trying all this stuff. If anyone who feels similarly or just as interested in general can feel that too, pretty much. Is there anything else? I don't want to actually talk about those here. Yeah, there's a lot of live coding environments that exist out there, some of which, and I'm more familiar with the musical ones. There's some of which, this thing called Tidal Cycles and Foxtrot, and Max MSP, and all of them have different like structures and are based on different languages, like Python and anything that you could kind of think of or might have heard of and encountered. I chose a live coding environment when trying to like get into this practice. I chose a live coding environment called Sonic Pi, which is based on Ruby, and it's its own language, but if you know Ruby, you know how to do Sonic Pi, and it's pretty beginner friendly. And I chose Sonic Pi because when I entered the website, which in fact is probably a good idea to show that out, it's already saying in the Google search, the live coding music synth for everyone. And I was like, oh, word, I'm everyone. This could work. That's cool. Let's click on it. And, it's very, like, uplifting. Like the future of music. I was like, word. And it's code-based music creation and performance, too. And as I learned more about this particular coding environment, I learned that every design decision that went into this environment was that nothing is added to this environment that a 10-year-old couldn't learn. Like anything that a 10-year-old, you couldn't explain to a 10-year-old, it's not really, like there's so many complex environments out there, actually, like tidal cycles and things like that. Like what differentiates Sonic Pi for me was that it kept things as simple as possible. It gave you this simple set of tools, limited your tools to like just the basics, and then you could do what you want from there. And that was like, at first you're like, oh, I'm going to do a senior thesis on something that was good for 10-year-olds. Cool. But it's actually, I got some pretty cool stuff out of it, pretty cool juice. And I'll show some of the recordings I've done, and I'm also going to show the live coding. But, there's just so many parts to talk about, so I'm sure that there'll be questions, but I want to make sure that I get through everything. And yeah, in terms of why, again, Sonic Pi kind of, live coding in general is like it promotes creativity and engagement, but Sonic Pi for me really solidified the accessibility issue where you could really, I know now after I've connected with some people in the live coding community, I learned that some people who do Sonic Pi, that was their first time ever programming ever. Like they learned how to program using Sonic Pi. and they came in with like extremely little to no programming experience or musical experience, which you can imagine is like, you know, would be really hard to do for like other projects. Especially if it's going to be something built for 10-year-olds. Usually 10-year-olds are not having like decades-long experience of music and programming, so you need to like be able to have it be approachable enough and accessible enough where someone who doesn't need music theory and someone who doesn't know how to program could possibly make something, which we'll actually try to maybe build a little piece today. I'll need your help doing that. And yeah, programming can be creative, engaging, and accessible. And while creativity and engagement are core aspects of the live coding landscape today, humanistic resources such as experiential behavioral testimonial documentation can make starting fresh with live coding less daunting and live coding performance more approachable. Which is basically all these web pages and me trying to do more stuff like talk to people like you. So thanks for coming today. So I could share all of this information with everyone who signed up to be here afterwards, and also like talk to anybody individually after at the end of this near the tail end of this event. But essentially this whole repo, all these web pages are, you know, there's a set of media where I have my code, any audio and video that I produced over that last semester, any documents that I had to originally submit, like the proposal plus the final report, a compilation of resources where it includes things like videos like this, that could be like inspirational things, or technical resources, or even just the few things or forums that are out there, like anything like that, just kind of good place to get started. Because I pretty much tried to build this for anybody who, like anything that I was like, damn, I wish that this existed before I did, I tried to put in there. And an archive of any artifacts learned, or artifacts produced during the process, which the whole thing, and most importantly for me, a journal, which is a place for informal writing. I'll click through a little bit of this, and then I'll probably just take questions afterwards. So yeah, it includes, like I could show throughout that I have like a SoundCloud, a GitHub, a YouTube, with some videos and audio files that I've had throughout the process, documents, not too important, resources, kind of has a lot of this kind of stuff in there, like in terms of papers, so academic resources, blogs, where I thought were pretty helpful, articles, all of that jazz, which is cool. Go to archive. Archive is interesting, because I was like, this is probably stuff that people wouldn't want to see, but that's exactly why I'm going to put it in there, for the people who probably do want to see it. And it kind of gives, the archive kind of gives insight into like how I went about trying to build all of this, especially since I was pretty much starting from scratch with a lot of this stuff, because I never met anyone else that does this stuff except for my advisor, so I didn't really have too much to go off of, but it just listed some integral tools that I used, like task checklist, are the descriptions okay, anything critical missing, just a little bit of insight into how my brain worked to try to do this kind of stuff. And then the journal, which I kind of structure in terms of like a collection, where if I wrote anything a little bit more paragraph-wise, I kind of went through my purposes, intentions, takeaways, all these off-the-cuff thoughts that I decided to like write down. I tried to organize them into different sections. Oh yeah, this thingy. I talked about that. That's cool. Yes, okay. And I think the most interesting part of the journal section is this play-by-play section, where how I learned. It's just kind of how I learned about. Okay, there was really little to no resources on how you actually go about organizing these codes. So watched YouTube videos and I wrote play-by-play, like almost like I was watching like the election or something, or like a football game. Like they started from scratch with this, and then they did this, and then this, and then they added this. And somehow I came away with something from that, so you might gain something from that. But yeah, that's the majority of what I produced from last semester. And before I go any further and show an idea and like maybe do a little demo, I wanted to ping pong it. That's probably not the word I wanted to use, but whatever. To you all, if you guys have any questions about anything that I've talked about or any curiosities or comments. I know I said a lot, so you can ask me about anything I said. Yeah.
Super cool presentation, first of all.
Oh, thank you.
I'm wondering.
What's your name?
Oh,
I don't see.
Henry.
Henry? Okay, it's me, Henry. Oh.
Our PhD student.
Okay.
And I was just wondering, I saw a little paragraph when you had something on digital audio work.
Yes, I can go over that.
Went quickly over it. And I was
Oh,
wondering,
yeah.
like, what role those types of software played in your creative process?
Yeah. So my first digital audio workstation was Logic Pro X. Or if it was GarageBand, but I don't know. I don't like GarageBand like that. So Logic Pro X, I encountered my first year at Yale, and I took a class with Conrad Kazmierek, professor of music department, who is now my advisor for the music thesis that I'm currently doing, which I don't think I mentioned that. Yeah, last semester was computer science thesis, this semester is music thesis, and the deliverables this semester is just an EP. So we'll do all that. But yes, I did that first, and I thought it was cool, being able to kind of work with the blocks and the graphical interface was really cool to see the audio waves, and I don't know, it was a cool experience, and I think the class really worked well because he really gave us the tools and knowledge to really get in, like granular control of like the inner workings of Logic Pro and like how to like really like, I guess let me reel back. For me, digital audio workstations worked well when I had a plan going in. Like I had a specific assignment or something I wanted to do. I knew exactly what I wanted the end product to look like, and that kind of helped me navigate. If you ever worked at a digital audio workstation, Zach, while I'm pulling up, maybe I could pull up Ableton. If you ever worked with one, they are huge. Like even if you buy like the free versions, there are like, I don't think even if you went in and tried to like play everything and exhaustively for a year, you would find everything in there, let alone if you buy like the most professional versions, like the suite or something like that. So yeah, it's really overwhelming to navigate those things, and to go in with a plan, great. Assignments, great. When I wanted to do my own creative practice and like figure out like where is my starting point, what do I want to do, or sometimes they're just like, yeah, let me just like make a beat, let me just do something. The pipeline from like something happening in my brain and an idea happening here to like trying to get a working version in the DAW, especially with how weird my brain works sometimes, it was like excruciating. Like I personally never really found my flow or my workflow with the digital audio workstation. So that was one of like the contributing factors, that paralysis I was talking about before, where I was like, I don't know if it's just me, is it this? I don't know what to do. Before I move on from this, because this is because it's important, I'm glad that you asked that, because it's important to kind of juxtapose the different ways that people make music and why exactly did I choose this one. So let me just add this to OBS very quickly. Window capture, that one. Yep. So this is Ableton, and already you could see that like there's all these instruments. These are folders with extra instruments, and these are all all of the instruments just for analog bass. And some of these folders have even more stuff in it and everything like that. So already in terms of sound selection, it's great. It's robust. It's awesome. But I don't know. It's just too many choices. And so I found that kind of difficult to wade. And in terms of trying to reference whatever I wrote beforehand, I talked about it. Yeah. Oh, yeah. Another thing about it is that you have to pay for it. The proprietary nature of these softwares, I mean, even if you want to get into it and get those like professional sounding sounds and stuff, and there's like really good reverb functions and like DSTs, like they're always wanting you to buy stuff. Like how many advertisements do I get YouTube? Whenever I go down a YouTube rabbit hole, even if I'm watching like Euphoria stuff or something, like all my advertisements would be like, buy this like MIDI chord pack, like buy this, all this stuff. And I'm like, But why? Like, I don't know. It's really, or by the sample pack. I liked live coding a lot because all the environments, no matter Sonic Pi and all the ones that that I've kind of mentioned and that I could talk about later, they're free and open source. None of what I've created today, I had to pay for any of it. Like, it wasn't behind any paywall. It wasn't, it wasn't behind a paywall. So already it became more accessible. And what was nice about Sonic Pi is that anybody that I introduced to Sonic Pi and I was like, hey, this thing, or I had this like code thing, I could save my code, send it over to them. They could paste their code in their version of Sonic Pi, and it was easy. It was just easy like that. It's text-based music creation, so being able to share that and being able to like engage with that was really cool, and like I guess regain the sense of like agency I've been kind of like talking about, which is a key point. So does that answer your question?
I guess some of these thoughts can be like overwhelming in terms of like what you said, like how many different options and instruments there are, so it feels like paralyzing in a way.
Yeah.
You kind of want to start from like scratch from zero and then like something else.
Yeah, exactly. I think only recently, now that I feel like I've gotten more comfortable in the live coding space, I've revisited using DAWs only recently, so maybe like sending out MIDI to a DAW, I guess is a good point. So live coding environments, they're not just like, they can just be everything is in the box, everything is like, you can do everything in the live coding environment, sound creation, like sound manipulation, arrangements, you can do all of that just within the live coding box alone, and you can make really good music. But I don't want anyone to come away with the impression that this isn't. It's just another tool. It's just another way of thinking about making music. It is compatible. If you are like really, really good and you have this really, really good DAW workflow that you've been using for like years and stuff, you can send MIDI. There's ways to communicate between your live coding environment and your DAW, like to use them like collaboratively. So it's not like you have to like abandon one practice and go to another. So like, do you have a DAW of choice? Logic, yeah. So like in Logic, maybe you have sounds there, which is cool, but you can do like, possibly I could show you how to like arrange the sounds in Sonic Pi, or arrange like the onsets of the sounds, like when you want to trigger each of these sounds, send that over to Logic, and so you can, rather than like, placing all the little dots and stuff for the MIDI and dragging everything and doing like the automation by hand or whatever, you could do all of that from Sonic Pi in like an algorithmic way. That might be a lot more intuitive and easy. So it's just another way of thinking about stuff. Yeah. Does anyone else have any comments or questions about anything? This is a lot of material, so I talked a lot. But is everyone good? Is everyone like following what I'm saying, sort of? Kind of? Okay, cool. I guess from there I can go into maybe, let's see. We'll go into maybe showing off Sonic Pi a little bit. So this is, that's not it. I gotta do it. Okay, that's me, and this is Sonic Pi. Um, so there you have your basic coder, as well as you have some stuff over here that I could talk about, where there's just extra settings that you could do, like a volume control, um, more preferences, and you have like a little log thing on the side, so I could kind of debug or tell what's going on within my code. But all of that's not too important. So how do you make a sound? How do you even start? Making sounds in Sonic Pi is pretty easy. If you just want to play a note, you say play, and then give it a little symbol, give it a little C, middle C. Let's do a little sound check, little louder than that. Yeah. Hopefully I won't blow everyone's ear off. So the play function can take either a MIDI note, which is, does everyone know what MIDI is? I can explain. Okay. I'm trying to like, all types of people coming today, so I gotta break it down. And let me know if I'm going too fast or you don't understand things I said. MIDI, imagine, do I have it? What did I do? That might be helpful. Unless I left it in the lab, and I did leave it in the lab, and that's fine. Okay. Well, imagine like a piano. So you're at the piano, and you have keys, and you could, you at least know enough to be like, okay, this key is next to this key, and maybe you know C, but maybe you don't know it's C, but you have just like this row of keys in front of you. Now, instead of like what musicians do, and you map those physical keys to letters, for the computer to understand what's going on, MIDI is like a protocol that instead of mapping the keys to letters, you map them to numbers. So C4 on the piano is like a middle C. So if your hand is somewhere in the middle of the piano, you'll probably hit it. But the computer can also understand that note to be 60. So same thing. So there's different ways of tackling it or understanding what's kind of going on. So that's the simplest way you can play a sound, and you can change like the synthesizer that uses that sound or the instrument. So right now what we did was, by default, it has this like beep sound. So, but maybe I don't want to use a beep sound. Maybe I want to use a saw. Maybe I want to do little rotating. So you could change like the timbre, the nature of that sound pretty easily. You can affect the amplitude of it, so quieter or louder. You can affect the, let's see, what else can you do? You could affect the length, so make it really percussive. Also, for anything that I'm doing today, the documentation and the whole document webpage thing I showed earlier, that's meant to be something as like a resource for anyone interested in like reading about it. But if anyone's interested in like getting into the technical aspects of it, what's nice about Sonic Pi as well is that if you want to learn more about anything that's going on, there's a very helpful and robust, show this off, documentation for everything that I can talk about today. So basically like a welcome, very welcoming. The welcome page, and it kind of talks about almost everything you could need to do like get started in terms of like, it was built so 10-year-olds can learn about computer science in an engaging way. So some of the basic foundational things of computer science are these concepts of like loops and how to iterate over lists of objects and things, or dealing with kernels and things like that. So yeah, all of that stuff is there and it's super cool. And even as someone who's been programming for a long time, I still made sure I went through and combed through the entire tutorial to really like understand and ingrain all the concepts really well, and it's very helpful. But in addition to that, we got some example files that are listed by levels of understanding. So you can go from just simply something like this, executing that, where this example is showing off that you can select, so RRAND says from this range of numbers, from -1.5 to 1.5, this range, give it a range and then randomly select a number from that range. So you could hear it kind of like you could hear it kind of playing back at different rates, either faster forward, or maybe like coming in reverse, which you can reverse the sample by making it have a negative rate, something like that. But basically, is that it's another way to vary your sound a little bit. And like there's still decisions in authorship that you have to determine what that range is. Like you can still have it like be something that's random. So I can write it. Maybe I can write it something like this. Oh yeah. Similarly, this chooses a random number from 0.2. So like, if I change this, go way back. So now it's playing the notes every quarter of a beat, pretty much. But let's like simplify this even more, because I didn't introduce a concept that is pretty clear, or not clear, is pretty foundational. So what you're seeing is a structure called a live loop in Sonic Pi, which is pretty much the bread and butter of the live coding, where you define like a block of code that you want to loop forever or as long as you want, and you define the contents of it, and after like it waits a certain sleep. One basically tells it wait this amount of time before re-executing that loop. So and then it just kind of loops forever. And the live aspect of it is that you can change the contents of this loop without like affecting the timing. So I think in regular Ruby you can have something like, I want to kind of demonstrate the power of this. You have loop do. Let's take that same sample. So it's just a bell. Let's have these things be the default. And first of all, let's not give it a wait time. You're going to get an error saying that, oh, this loop did not sleep or sync up with something. And basically, it's complaining because, like, if I want to clap on beat to a song or something, I kind of instinctively know when to, like, wait and to be in time, right? But the computer doesn't have that, like, knowledge, you know? It's just I'm instructing it on what to do. So technically what I just told the computer to do was until it, like, crashes, like, forever and stuff. But now if I wanted to kind of go on beat, now that pretty much, which is cool. And in terms of another contextual thing, in terms of like what these numbers mean numerically, I'll explain this part and then I'll take your question. Sleep 1 doesn't correspond to like seconds, right? Like not 1 second. It corresponds to 1 beat. So by default in Sonic Pi, the BPM is, or beats per minute, is just 60, which, you know, technically if you have 60 beats per minute, there's 60 seconds, you'll just pretty much it'll be synonymous with 1 second. So it'll sound the same. But if I want to get a little dancey, you know, most of the music that we listen to isn't, you know, just 60 BPM. Usually it's like 120, you know? And you'll hear that the speed, even though I didn't change anything within the loop, it will double to reflect that. So musically, you're kind of working within, you're kind of like having to use your musical brain as well as your, you know, developing programming brain, and to be able to understand everything that's going on and make your, you had a question?
Yeah, actually, I feel like you kind of already answered it, but I was just wondering how, like, more relative ways of thinking about rhythm, like quarter notes and half notes and whole notes, whether that's something you played into the live coding or whether that's not something the computer really has any use for because it thinks of everything in terms of BPM.
Yeah, well, the computer doesn't think anything. It's like you're telling the computer everything to think, right? So, like, in terms of, okay, you're coming in with some music things and you're thinking about concepts like quarter, how do you imagine quarter notes and half notes and all these note values? Well, essentially what you have with Sleep 1, since it corresponds to 1 beat, is 8 note, right? So if you give it, like, if you were like, okay, so right now what just happened was that I was playing on every quarter note, playing right on the beat. If I wanted to play eighth notes, right, which is just half of a quarter note in music, then this is what you want. You can do that numerically. Let's say you don't want every time to like to write these numbers, right? Your brain doesn't really think like that, and when you're live coding or doing things really fast, you don't want to be thinking in a way that's unfamiliar to you. let's take, like you said, let's do something. Let's make Q equal 1. You make these variables that will be the symbolic representation of what you want. So we have a quarter note. Let's do E for eighth note. Let's do H for half note. W for whole note. And these are just, this is some getting into some music theory things. I don't know how many people know these note values and things, but this is just an example of like a different way to think about it. Let's do S for a 16th note, which is a quarter of a quarter note. And let's do T for even dividing that again. So now that you have these variables, instead of every time, if you're building something out, writing 0.5 or 1 or whatever, now you can just write. So now it's playing every whole note. Now we want it to play a little. Now we're playing it every half note. This is back to the quarter note. Oh yeah, that was what I was trying to demonstrate earlier. But this is our eighth note thing, right? And you can remember in your brain, okay, E is eighth note. You can write it in the shorter way. You could write it out completely, you know, whatever kind of way you want. You can kind of, like, I have a certain way of building out my performance practice, but you can customize it to whatever, like, however brain works, you can do that. So if you want to write it all out, same thing. So what this kind of demonstrates, though, earlier, I was trying to, like, get into it naturally. I wanted to change the contents of the loop and have that loop continue going. Change the contents of the loop without affecting the flow of the music. So if I wanted to change, I'm going to execute this, and midway through I'm like, actually I want this to play every quarter note or something like that, right? This is what happens. Now let's go back to quarter note. So that's not really what I wanted to do. It sounds kind of cool, but that's not what we wanted. Basically what happens is that the loop that I made before when I executed the first time, that kept running. And then now that I re-executed the program again, it made a separate loop that they're both running at the same time. And it didn't change the contents of that thing. It didn't do that thing. That's where live loop comes in. Where you can, there you go. You can change the contents of this loop live without affecting the flow. A key part that you'll need for it is a name that you'll be able to reference that loop by, so it knows when I change the content, so it'll be like, oh, change block. So if I try to run it without a name, it'll say, it needs to have a unique name. It's also very helpful when programmers make helpful error messages so you can know what's going on. You know, that's great. So, oh yeah, it needs to have a unique name. For example, this. I was like, okay, that's as good a name as any, foo. So now we have our quarter note. We have our quarter note loop going. Now let's change that to eighth note. Change the 16th. Yeah, beat drop. Where was the beat drop, everyone? Where was the beat drop? But yeah, so like you could kind of riff off of that and manually do your own beat drop and then just wait and stuff like that, which is pretty dope. So that's how you would that's the crux. What you just saw just happen is the crux of what makes this so dope and what gets me hype, and hopefully anybody who wants to get into it or see a show or anything gets really hype. You can really just even try to riff off of that. Maybe do a little demo. And just I'll just be changing stuff, and you can try to infer or like by the variables that I'm changing, just like zoomed in more, kind of infer what exactly is going on. So, and I'll use the variables from before. So let's start with just the regular quarter note. Just do a little demo. Let's reverse it. Oop, did I stop it? I stopped it. Whoops. So that's the sound of it reversed. It's gonna phase out. See, for that, the length of the sample runs longer than a beat. So they're gonna, even though I'm changing the content, something would have already been triggered, and sometimes I don't want to continue hearing those lingering notes. So let's see if I can compress this sample to just be equal to one beat in this BPM. So now it's pretty small. Kind of wanted to. Now it's the length of two beats, but 4 beats. This sample is very long. Holy shit. Okay. Excuse my language. Let's do something else here. How can I make this better? Oh, I know. Let's I don't know. So start basically is like telling me start playing the sample at 75% of the duration of it. So I'll basically be starting like 3/4 in, which you won't hear anything if the sample is just playing at the regular speed because it's percussive and silence at the end of it. But if I get the end of it, is it gonna do what I want it to do? It's gonna do what I want it to do. It's gonna do what I want it to do. Oh yeah, it's so soft. This is such a weird sound. You know what? I don't have to use it. I can just change it. There we go. Let's just work with a bass note. That's good. Put a little patch on it, a little dampener. You don't want to be louder. What else do I want to do? I kind of want it to be fast. I'm just playing around. Maybe I want to add another step to that. Maybe let's bring in a snare sample. So same rate. Have an alternate maybe. That's cool. That's simple. Kind of like your words here. I kind of want it faster, but like I want to keep the relationships between the bass and snare the same. So I'm just gonna change the BPM within the loop. Let's get it so go faster. So even faster. Let's double time it. So I just kind of told it to go twice as fast. Maybe 3 times as fast? Alright, let's go back. So there's a lot that you can do with here. And this is very just small example, but you know, in that small tiny demo, and I'll show off some of my longer things or things I've done and how far you can really take it. But even that, I mean, imagine, like I want to ask before, and then I'll take your question, Vinu. Imagine how long it takes to do that in like that workflow. Imagine transferring what just happened, what I just did, a DAW workflow, you know? or like it's not the same. This is very like you can do this live in front of people. I'm doing it, and just kind of make decisions. I'm just changing my mind, and then affect music in real time. And you can imagine, my ideal performance environment is a dark basement with like very sweaty bodies, and everybody's just banging their heads and stuff. And I'm kind of feeling the vibe of the room. In control, with a DJ, there's a sense of control that I can have in like making everybody wait for that anticipation and wait for the beat drop. But here I can really make them wait. Like I have a lot of control over anything I want to do, which is pretty dope, and make decisions on the fly, which is I think the biggest plus for live coding. And it's relatively simple, as you can see, to like kind of, it's almost like writing an essay in a sense, right? Like the variable names can be very intuitive, almost like you're reading what's going on. Like I see live loop, I assume that this, whatever's inside of it's going to be in a loop. It's going at this speed, and like, oh, it says sample, BD, it's playing a sample. You can infer something, so it's cool. Or at least I think it's cool. I hope I'm convincing you all that it's cool. But Vina, you had a question? You get errors, yes. Well, this is where it depends on the environment you're in, and even within this one, which I could speak on, more than anything else, it depends on the context that it's in, really. How do I demonstrate this? It really, to understand, you know what, I'm just going to show. I'm just not going to talk about it. I'm just going to show. So let me make in the stock, a mistake. What do I want to do? Okay. I know what to do. So I'm like making a decision that I want them to go faster or something, and I accidentally comment this out. It's gonna, just since this is the only thing playing, there's no more sound anymore, and that's what happens. That's what happens in this context, this kind of error. That's that. There's different situations, right? Let's restart it. That's another error. That's another error. That computer doesn't really understand what that is, and since it was within this live context, it's almost like every time it's reading through top down, and then it stops, and it's, what is this? And then it doesn't run anything afterwards, so the entire loop just like dies, unfortunately. It's a very sad death, thread death, very sad death. Not the way you want. Go back. Let's say I do the same thing, but outside of the loop. It's outside of the loop. I still got an error, but it doesn't affect that live process, which is happening like parallel to everything else. So I'm pretty good. What if I make an error about, let's change what to. So I just made the sleep time to faster. I changed it from 1 to half a beat or whatever. I made it, I changed the quarter value to be 8 whatever. But what if I give it like so that kind of error can also like make the thread die, which is unfortunate because that variable is being used in that thread. So it really depends on what kind of error it is. A hack, or rather, once you get used to it, a language feature perhaps, not a bug, is let's do the same situation. So not that. There we go. Okay. So let's say I make a mistake and I don't want this loop to die, right? So there are ways to continue running, like, as I'm saying this, I kind of don't want to backdrop right now. There are ways to, the same way how live loop thing, this thing runs parallel to everything once I already started that process. There are other functions that are variable that can, this idea of like running parallel processes, like you can play on that to have things like not break, or if one part breaks, the entire thing doesn't just crash down, pretty much. And it sounds weird and complicated, like, oh, parallel processes, parallelism. I'm sure anybody who's ever done any programming really hates that concept and everything like that. God bless you if you never heard of it, because you don't need to. But it's very synonymous with just when you see a band, right? Like everybody's minds and everybody's operating in a, like everyone has their own parallel processes, right? Like the saxophones are not completely dependent on the trumpets and not completely dependent on the drums, right? They try to sync up, but they're all running parallel to each other, and this is like very similar of a concept. So what I'm doing here, I'm saying, let's see, what is this function? Asynchronous time. It basically will run this block. I'm going to encase this part, this little thing that I have right here, in its own little parallel block within this loop. I'm still going to give the loop a sleep time. Well, actually, let me just showcase that. So the loop ran. I defined it. It played this part because it wrapped down. But I have to zoom out now because you're not going to see anything. I have to zoom out. There we go. It played it. It read it once, and then it saw that it didn't sleep. So I got it now. Now I have to re-put those sleep lines because it's not reading these. Because now it's its own parallel processy completely. So now I think that's equivalent to sleeping for 2 beats, right? Or let's do, yeah, so when I change it. So, how should I just, oh, actually, no. I'm gonna, okay. Let me do the same thing I did before. So, that's not a number. It's gonna give me an error. So, what's happened now is that bigger loop here, like this upper structure, this wider structure is still running. It's still reading top down, but it's coming here, reading this, and it plays the bass, but there's an error here. And so this parallel thread, it never like continues forward, but it initiates this and then it goes here. Like I guess there's like I'm trying to like explain this process, but essentially like now I've encased this in its own parallel processes. Whatever happens to that guy, it doesn't really affect the bigger guy, pretty much. Bigger guy can continue marching along as much as it wants, which is great. But what's nice in a live performance is now I can like fix that issue. So now if I want to fix it, please fix it. Wait, hold on. What is? Why can't I? This does sometimes happen. Let's see. Can I even type? Yeah, for some reason I can't type. Oh, okay. Yeah, I hate this error. Okay. I have to time this very much. I have to time this. Hold on. Come on. Okay. Ah, this is the worst error. I chose the worst example, but it's still good. Okay. Yeah. Okay. I mean, that's the worst kind of error because for certain errors, it will like pause. It will like prevent you. It will like prevent you from typing for a bit. Like it'll just freeze the whole thing. So I have to like hack at it like that. But not all errors are like that. It's not always like that. But it's also being very transparent about what happens. But, yeah, it's a Sonic Pi feature. It's a Sonic Pi like little characteristic, little quirk, I guess. But all of these languages have their own things, right? Like it's really the architecture behind allowing us to like write these systems is pretty complicated, and stuff is not always going to go right. So you try your best to like kind of separate things, and there's a lot of ways to try to handle that, which I wrote out in my thesis and stuff, in ways that I was like, oh, this is a problem, and then I tried to find workarounds and stuff, and so that's like a journey that everyone one could go on individually and all of that. But yeah, this was a short little demo. Does anyone have any questions about the demo or anything like that, or wants to see anything? Yeah.
So obviously, like visuals are kind of a really important part to like what you guys are doing. Is there a way for like to like map out visuals to things that you're doing, or does it need to be kind of like a side-by-side process? Like someone is also like working visuals and then you're also live coding music, or is there like a sort of point for like things and stuff that you're doing visuals and stuff like that?
Yeah. So yes, there or no, that's not that's not the correct short answer. Yes, you can sync them up. There are protocols and ways to do that. To kind of tell another program that's making the visuals, because this isn't a program to make visuals. Hey, I just played a note, like make the screen flash or something. Sonic Pi does have ways to communicate like systematic, pretty much. It's this thing called, this is getting into a little bit more complicated stuff. I won't go deep into it, but I will mention it. It's this process or this protocol called OSC, or Open Sound Control. And if you are interested in like building stuff on your own and like want to talk to me about it later, or go off on your own and do it, almost every modern like software program out there can communicate via open sound control. We have a motion capture system here at the CCAM that can communicate open sound control, where you can attach tracking balls almost to any object. And like I worked with actually great colleague Ross, who we had like a little thing with tracking balls on it, like a little badge. And as we were able to map the height of it as it was moving through space to like pitch in Ableton and stuff like that. So we were able to have Ableton and the motion capturing software like talking to each other. Similarly, you can do the same thing in Sonic Pi, where you can map, like you can send that OSC message from the motion track to Sonic Pi, and then have the same thing, having it be mapped to pitch or amplitude or speed or like how percussive that sound is or how lengthy it is. That's not a visual example, but that was the most salient thing since we're in this room. But similarly, you can have it the way that I just described that process. You can do that with almost anything. Unity is slow sometimes to put up, so I would put it up if I had more time. But I was interested in maybe making like an audio-visual experience using Unity, where Unity is a software that it's most notable for making games. A lot of games were made in Unity, or stuff like Unreal Engine or whatever. And more agnostically, it could be just used to make any like 3D modeling or animation and whatever kind of projects you do. It's really cool if you haven't checked it out yet. But I had Sonic Pi tell Unity, hey, I just played a note, and then I had like this cube Unity that would change color randomly every time, and I got really excited when that worked, even though it was just a cube changing color, and I had like a little rave in my room, and it was great. But you could take that simple process, that simple proof of concept, right, and then extend that into like almost anything. And even you could have that always controlling any kind of processing, but there are people who live code visuals, and I could be live coding music. There could be someone live coding visuals, and we have our own granular control. But there could be like a thread between us where like certain variables and certain elements of what they're doing visually, I get to control using the music. And we can make that a bi-directional process for certain things that are happening in the visuals. Like let's say there's a lot of on the screen that can affect some sound. So you could really, it's not a one-way process, and you could really go as deep as you'd like with it. So, yeah. So actually too, I would like to just very shortly, because I mostly know music, but if anyone is interested in visuals, since I want to talk about live coding in general, I want to show, nope, not Ableton. We're back here. Let's go here. And I told you about this yesterday, so if you look up Hydra, it's this browser-based live coding environment for visuals that it says all of that pretty much there. You can read about it, but you could basically get in there. And what's nice is that as someone who, let's just assume I have no idea I actually have no idea what's going on. But even as a pro, could figure it out. But even if you're not a programmer, you have no idea what's going on. What's nice is that it takes like user-based, like, it takes creations that people have used, and you can like randomly, with this like shuffle book, and randomly like find things that people have created online. And then once you like stop on one that you think is like cool or something, like this is pretty cool. That's pretty cool too. Ooh, oh my god. Ah, wow, these are all amazing. Let me stop on this one. You can edit that code too. So I have no idea what's gonna happen, but let's see. Let me take this. I don't know what this variable is. Let's make this number, instead of 30, let's make it like 5. I don't know. I'm gonna press this play button because I don't remember how to do it. Did I change anything? Sorta, maybe. Maybe I make these variables 0. That usually does something. Something's not 0. Okay, 0. Let's see. Oh, actually, I should probably just. Oop. Oh, I made it stop moving. That's amazing. Oh, now it's just, yeah. So I have no idea what I'm really doing, but it's cool. And as I continue to try to do it and play around with it, it's very like engaging, where just using context clues without me even like looking up the documentation for these functions or anything, I could kind of just start to figure out what each of these variables do. And if I really don't like it, I could just continue shuffling through, which is pretty cool. So that's it for a Hydra demonstration. But yeah, does that answer your question? All right, cool. Does anyone else have any questions? No? Okay, cool. I'll play a few seconds of some. This is my SoundCloud of a few things I posted that I produced using live coding, just so you can get a sense of like at least the stuff that I've been doing. But you can make all kinds of music with it. I think it's important, and what I try to do is make music that. I don't want to say that. So that live coding can make any type of music. That's kind of what I want to do. Because when you look up a lot of exhibits online right now, a lot of them are very like classically electronic music, like what you think when you hear the word techno and EDM, like that's fine, which is dope, which is absolutely crazy dope. But this is just a tool, right? And like you do a lot with it. So I'll just play all these examples in the variety, even between this stuff that I'm making, can show that you can really take it in whatever direction you want. So let's hope these play. Actually, let's do that first. It's a good idea. Okay. I just made that using like one sample, and then I just cut it up and did all this stuff with it. And it's not my favorite sounding thing, but I thought it was cool how much I was able to get out of just like one sample I randomly found online. So that was cool. This one I like more. So this was cool. So that's the vibe of that one, which is cool. That one's a little slow, but I'll play this one. So, yeah. I'll kind of skip through this one. This was a recording of a little live coding session I had in New York. So you'll hear me do something and then, I'll wait until this part, but you'll hear me do something and then kind of pull back a little bit. I hope I don't break this. Yeah, cool. Yay, cool stuff. Is there anything else that I kind of want to show? Yeah, I made this kind of weird synth, very like dark synth kind of vibe song. So I'll play a little bit of that, at least the beginning of it.
Dispensable to me. My wife is not.
Yeah, so that one's kind of quirky and fun. And I guess the last one I kind of want to show before I get into trying to show some stuff that I've been working on is this was the first, what I'm about to play was the first live coding like practice session ever recorded, and because of that and also how dope I thought it was, it's my favorite. So I basically had made, I wonder if I could find it, then I will maybe do a demo with that. But I basically just made my own jump loop, and then this was when I was still learning about what all these effects do, and I didn't know like how it exactly would sound. So everything I'm doing, I'm just slightly tweaking something. It would slightly tweak an effect and make it like more and more prominent and be like, oh, okay, that's kind of what it does to the sound. Like it makes it more muffled or it blasts it or whatever, and I'll figure it out. And then it just collectively just gets crazier and crazier and crazier. So I'll let that play. So I might actually, since I have time, I might actually let this play a little bit, but I'll let it for another example. Yep. Yeah. oh. Yeah, that was another. But yeah, that was an example. And I am open to any more questions or comments and anything like that. And then I'm probably gonna just try to do a little practice session in front of y'all. I was just trying to figure out which piece I wanted to play or wanted to do, so I'll do that live in front of you for the last like 30 minutes of it. But I wanted to open it up to any extra questions about anything so far. Yep.
In one of them you had like some puzzle parts. Is that also sampled within SoundCloud? Do you have to like link up to something else to get those?
Yeah. Sometimes I just find my samples on free sound, like either online or something like that. Sometimes what do I do? It really depends. It could come from anywhere. I could do it live. Thank you for coming. I could do that live. I don't know. It depends. Like, I think the sounds that I was using, like, in any of these clips were all samples that I just downloaded or had, and then then I just manipulated them within the program. How I was showing before, with like either changing the rate, changing like the direction that the rate is doing, and changing the amplitude, changing the effects on them, whatever. So yeah. We're good? Yeah, are we good for a demo then? Are y'all? Okay, cool. Great. Let's hope it works. Hey. Let's see. Let me change the screen back to my little my little stuff over here. Let's change it. Not to Ableton. Oh yeah, that's not me being delayed right now. And
Would you mind moving a little bit further back?
oh yeah, you're right. Nope, it's all good. I was drinking my coffee. Nope. Okay. I'm just gonna do it like this. Nope, it's okay. You're all good. That's part of the live coding, everybody. You can do that. Okay. What I've been doing, I want to shout out OBS Studio because it's been changing my life. It's so cool. It's this free software, open source, free and open source, name of the game, that is allowing me to stream on Twitch right now. I've been live streaming this event, and I've been able to kind of overlay all of these visuals. Like right now, I'm using OBS Studio on that computer over there to project it all to all of these projectors, and then I'm using OBS Studio on my personal laptop to point to myself, like video capture myself right now, and then I'm streaming that on a private YouTube broadcast, and then I'm logged in, I'm on that broadcast on this computer to get the feed. So it's very, you know, I figured this all out in like about 2 hours before the event to try to make it a little bit more exciting. But yeah, it's been very janky, but I'm very appreciative. And I mention it because I made this little, well, let's interact with this. think if I just, yeah, there we go. Yeah, made this little like overlaid visual thing where, I mean, you're not gonna see it because, I mean, it's gonna wave super delayed. I'm gonna look so weird. It's fine. Kind of made myself transparent and made like this YouTube thing I found transparent, and you know, can make cool visuals. I'm not live coding my visuals, but they're still cool visuals. In fact, for this as well, on the first panel here and on the last panel back there, those are also, they're recordings of live coding practice sessions that I did that are available on YouTube, where I did a similar thing that I just showed you right now, where I just overlay these videos that I found online or are broadcasting, and I make some of them transparent. And my code editor actually just looks like this. This is what I see on my computer when I'm coding. But what you all see is I make the black part transparent to try to make it, you know, cool looking, because I like cool looking things. And it's enough talking for me. I'm going to just try to play some music. I'm going to attempt to. I have no idea what some of these sound like, so we're going to figure that out. Let's see. Ooh, yes. I cannot play that one right now. What does this one sound like? That sounds cool. Yeah, let's play with this one. What am I even doing? Oh yeah, okay. That's a good starting point.
Dum
Yay! But, yeah, in true unexpected fashion, just a lot of unexpected stuff kind of happened, but you know what? I'm proud of it because I think it's in the nature of what it is all about. I mean, so yeah, I hope you all enjoyed. If there's it's pretty much open for questions or anything like that. If you have any questions about what just happened on the screen or anything going on, and I'll be here for a few minutes. And yeah, I mean, I just want to take a moment to say thank you all for coming and you know, showing up and hearing me speak for like about 2 hours and stuff. You're the real ones. So yeah. Thank you. So yeah, that's all I have to show for today, for right now. But we'll be able to, you know, contact me either by email, like roxanne.harris@yale.edu, or could either follow, like, or check out my SoundCloud with some of the stuff that I have on there. I'll have a link. I have a link to all of this stuff. I have a link tree, so I think I'll just do that if anyone's interested in that. Also, come up to me afterwards if you want any more information. But I think I get everything on here. So yeah, I'll be here. So yeah, but thank you all for. Yeah, feel free to hang out and ask me questions and stuff. Yeah. So, what's good? Yeah, no, for sure, yeah. So, yeah, no problem. Thank you for coming. Yeah, thanks.
What does it do? Sorry, I missed it.
Oh, no, it's cool, man. It's cool. Hey, one sec. Hey. No, you're all good. Hey.
Oh, so cool.
Yeah, thanks for making it. Unexpected stuff. You know, it's cool. I was just mad nervous. I was like, I'm talking in front of so many people. I haven't public spoken in like I don't even know how long. Like I don't do this stuff. So I mean, oh yeah, thank you for anyone who tuned in on the live stream. I will be ending the live stream now, but very much appreciate the love. Yeah. Okay.